is going over null hypothesis, alternative hypothesis, and essentially how to assess and find the critical z value. Now, in this case, we have alpha equals 0.025. And this is our answer, actually, but I wanted to show you how we get to this point. And so one of the keys first is whether or not this is a one or higher curve, or is this only looking at one side or one tail, left side, right side, lower tail, upper tail, left tail, right tail. It kind of depends on your, however your vernacular. But in this case, what we're doing in Excel is a norm sine function is the function of choice for finding z value. So you'll notice norm sine, but some Excel versions, newer ones like mine, also have this one, norm SNN, dots. There's two dots in between. They're the same function, just updated slightly. And so what we're doing here to get the z value, because it's a one-tailed test, we're going to do a 1 minus. Now what are we subtracting? Well, alpha. Alpha, we're going to find the alpha behind the, or the area under the curve, 0.025. 0.025. And this is what we'll find our z value, as you'll see. And then likewise, null hypothesis equals 0.3 for the second example. Alternative is less than 0.3. Is this the same? Is this a one or two-tailed test? Well, as again, the tail is this sign. It's greater than or equals to. Both mean and translate to a one-tailed investigation, because we're not looking at both sides. We don't know. We don't care if the up or the lower. We want to care if it's less than, in this case, where alpha equals 0.005 and n equals 175. So what does that mean? Do we need n in this case? Do we need n to solve for this critical value, this critical z value? Actually, we don't. Just showing you as an example. So it's essentially the same thing that we're doing. I'll use the traditional norm sine function just to show you that it's the same. So our 1 minus, as you can tell, and now 0.005. So that gets us to our z value for this one, as you'll see. Z value of 2.75 or 2.6. Now our last one has a few wrinkles to it. The null hypothesis equals 0.3. The alternative is that it doesn't equal 0.3, or alpha equals 0.025 and n equals 175. Well, first off, we know that we don't need n in this case for assessing the critical z value. And second, this is the first time we actually see an equals and it does not equal. And what does that mean? That means that this is a two-tailed test. So what does that mean? What does that mean for us as we try to find our z value? Well, first and foremost, for a two-tailed test, we need to divide alpha by 2 because it's a two-tailed test. So first off, what we have to do is our 0.025 divided by 2. That is our updated alpha for one tail, because we need to split this up in order to do it correctly. And then secondly, now what we'll do is our norm sine function once more. And this time it's a two-tailed test. And so we just put this in here, and then we'll get this. Now what does this mean? So a two-tailed test is negative 0.24, but also it is positive 2.44, as you'll see. So both. So that is what we're doing. We're going to subtract to get this. This is our one side, and this is our other side. Oops. As you can tell. So that is the z value, critical z value for the left and the right tail, or upper or lower. So that kind of concludes this problem so far, and just feel free to let us know if you have any questions along the way. Thanks very much. Bye-bye.